Welcome to APDesign Digital Tools. So for this video we're going to talk about aggregating components across a larger set of information and data lists. So what we are going to do is basically let's say that you wanted, this is being built from the Spaceframe 301 video. We have a space frame here. Looks pretty complex already, but let's say that we wanted to add even more tectonics to it. So say each of the web members was going to have a profile extrusion something like this. You can imagine the Herculean effort it would take to basically build each one of these into this very custom space frame. Nobody would want to do that. So what we're going to do is essentially going to build this same component into Grasshopper and then aggregate that across the entire space frame. A little bit memory intensive, but you'll see how quickly you can kind of make complexity your friend. Alright, so what we'll start with is that I'm going to use this line and this little space frame as our kind of starting off point. So let me turn off the rest of the space frame so we don't get confused. And I'm going to add a curve component. And this curve component, essentially what I'm wanting to do is build a circle here and a circle there and just basically loft between them. And maybe then build a larger circle and then do all that on the other end and extrude across and then have the other set on the following side. So pretty simple. I've started with this curve. I'm going to now use a curve under analysis. I'm going to use this perpendicular frame. And the way that this works is you give it the geometry of the curve, and then you can give it values to evaluate and place a perpendicular frame on the curve. So if that curve happened to be sloped, then you would start to see it, sloped. Like say if it was on this, that would rotate that frame. And so I can move that along the length however long I want. Now at the moment it's just going toggling between 0 and 1, so it's literally 1 inch along that curve. Now I probably want to change this parameter slightly and kind of give it a larger value. So I'm going to have it round to like one place, maybe go up to 3, and we'll call this the length of taper. Alright, so that's well enough. I have that's moving to 3, but what do I do about the other end? Let's kind of build these things simultaneously. So what I'm going to do is find out the length of the curve, and I don't really care how long it is, but I do need to have that information, and then I'm going to simply subtract the length the same amount. So let me add that to the T. And now we're going to see that frame on the other side. Great. Alright, now the reason I'm using that is that when I use my circle component to build, it needs a point. Well, this represents a point also, not just the frame, so I can give it that. And then it also needs an orientation. So right now it's set up to be in the XY plane, but we want it to be actually in whatever plane that this frame is in. So I'm going to give that also to it. And you'll see that on the screen now we've built a circle that is flush with that frame. So now all we need to do is give it a radius, 1 being its its default value, and I want this to be smaller, so we'll just like start to shrink that somewhere in there, and we need to call that out something. So this is like the inside taper radius. And then we also need to build a circle then at the beginning and at the end of the circle. So that's easy enough. I'm just going to copy these two pieces of information, move them down, and then I'm going to give them specifics. So 0 being the beginning and the length being the end. Now it would help if I knew exactly how I put these two in. So I want to make sure I put these, attach these in the same order. So first I'll detach, and let's take a look at this, see if we can't see how it was attached. It looks like length of tapers first and then the subtraction next. Okay, so in that case I'm going to go 0 first and the length of the curve second. Alright, so now we see that we have a second circle built at the beginning and at the end. That's also going to need its separate radius. Let's say this is the outside taper radius, and that's going to be smaller, and we'll attach that to there. And let me get rid of these. I'll disable the preview. So now we see that we have those two circles. Great. Alright, now let's see what we can do to loft basically this one to that one. Now if I look at under a panel what I have in there, I have two circles. This is representing these the inside taper, and then I also have two circles representing the outside taper. So if I'm going to loft, I'm going to need to weave and basically start with the outside and weave it to the inside. So I'm going to use a weave component, enter in the outside, then the inside, and if we look at the loft from that, we'll see that the loft is kind of doing this strange thing where it's continuing. In fact, all I want to do is go to here, period. So in the weave, it's woven all four circles. Actually, I just want to weave two of them. The one of them from the outside to the one from the inside. So I'm just going to graph those. And we'll see now we have two lists. We have on one end the outside to inside, and on the other end we have outside to inside. So that actually works pretty well. So that's essentially that part of the taper. And then I'll want to loft the rest of the length, and that should be these guys. And that seems to be working relatively well. Alright, you might notice that I actually have a little bit of an offset here. So if you want to kind of build that kind of specifics into the model, it's pretty easy. Essentially, I'm just going to grab these two, and I'm going to make a new taper. So this is going to be the rod radius. So that's going to increase a little bit, and I'll just use that and replace it. So now we see we're getting a pretty close facsimile to the one we did. Maybe not quite as elegant, but that's why we are parameterizing it. Now you'll see a weird thing. You see that little fluctuation? That's due to the loft being kind of very generic. So if you want to get a little bit cleaner, you may want to do a couple of things. The loft option, you might use straight. So you can see here that straight would be number 3. We'll plug that in, and we'll plug it in here. Let's see if that doesn't take care of some of the, still a little unhappy. The other thing you can do is adjust the seams. It's false. We'll set that to true. And so that should take care of most of the issues. So it needs to be tapered a little bit more, maybe. It needs to, this one needs to be a little larger. And that's getting to be a pretty close facsimile. Excellent. So the last thing you might want to do is that if you bake these, you'll notice that, and then we kind of close grasshoppers, that they're hollow. It's probably not what we wanted to do. So we're just going to cap them. And now if we bake them, you see that they're kind of a solid piece. Alright, so that gets us kind of to, at least to this point, in about 10 minutes. Now let's populate the world with it. Let's test a couple of ways to do this. I think the first thing we want to do, I think we're good. Alright, so let's just try it on a smaller test sample size. So I'm just going to move it over here to the end. Let's turn on some of these, find out what they are. Alright, so these are the, and we'll turn on these. Okay. And last one, turn on that. Alright, so these are all the web members. These are the bottom pieces. Alright, so this is a polyline, and so in fact what we would want to do, it's a long polyline, so we actually want its segments. So we'd want to explode it and just get the various segments from it. And let's just go ahead and plug in one of these into that. Okay, you can see that we broke something almost immediately. Let's see if we can't, let's take a look at what we're getting. So we have a series of these. Let's go ahead and graph them here. So it looks at them individually. Alright, so you can see that we're immediately having some issues with getting the tapers in the right place and connecting everything. So we're going to troubleshoot a little bit. I think obviously when you get a red angry component, you know you have issues. And so you always start from the left and go to the right. The hope being that fixing these is going to fix that. So I think that there can't be anything wrong with the geometry, but there could be something going on here. A lot of information is going in, and this one. So what I'm going to do is simply weave these together too. So essentially it's going to put a 2.3, the length of taper, and this in a series of separate lists, and I think that should help. Okay, so that works for that one. So let's do the same thing down here. Now, again, we want to make sure that we're following the same order. So this one will be that, and the 0 will be in there, and let's plug that in. Okay. Then magically we start to build that up nicely. Alright, so in theory, and it's always theory, we could add those. And in theory, cross your fingers, we could build in those. Almost worked. All right, let's do one at a time. All right, so then there's something quite a bit angry about that. So I'm going to graph these here. So that's good. So the important thing here is to get like-to-like information. So after a little investigating, what we did here was we exploded right before we entered into the curve. So even these lines, you would think they would be pretty basic. They need to go through and explode. And we'll just put their sides also in here. This may take a while. We're starting to get quite a bit of information. And then the same would happen here. We have back here with these this D wrap, we have the edges. But if we look at the panel on them, some are planar, some are linear, and we really need them to be broken down to be straight lines. So what we're going to do is we're going to just create a polyline connecting all the vertices. I realize that once you do that, any curved form is just going to be segmented. It won't be kind of a pure curve like that one. It's now going to go straight. So it could mess with your geometry a bit. We're going to use that polyline. We'll bring it also over here, and we'll go ahead and explode it. And so this would be the completion of our build out. So you can see now, and it looks like about 18 minutes, with a little bit of troubleshooting, we've managed to make a very specific kind of space frame. And if we turn back on the sphere, you probably have to mess with its radius a bit. We could see we even could Boolean out these connections, and we would know very specific to manufacturing kind of the angles that we would need to connect each of these pieces to those balls. Alright, very good.